Like I said, this one had very little code changes here, but let's go ahead and take a look at what it is that we're trying to fix up here. If we come to our profiler right here, and then I hit record profile, and then we force re-render, and then stop that profile, we'll get that render right here, and we'll notice that everything in our app is re-rendering, all of the things. And that's confusing because if we come down here, we see, yeah, okay, we're not memoizing the app provider with react.memo, but we are memoizing the grid and we're memoizing the cell, and those are probably the two most expensive components that we have in our code base because maybe the grid is doing a bit of heavy lifting and the cell is being rendered a lot. So we're memoizing those so we don't have any problems with that. But you notice that the memoization isn't helping us at all here. We're still re-rendering a ton of stuff. If we go to the ranked view, then we can just scroll for days. And yeah, there's something going on here. And if you look at each one of these and see why it rendered, okay, so why did our grid re-render? It's because the parent component re-rendered. And actually that's I think a bug in the DevTools because it's not because the parent re-rendered, it's actually because our app state context value changed. And that's one of the things that could trigger a re-render for a React component is when a context value that it's consuming is changed. But the funny thing is, if we go down to our app right here, this force re-render, this is just going to trigger a state update, which will trigger a re-render of this app. So we're not actually changing the grid state value here. That grid state value actually stays the same. So why are we getting a re-render when the context value has values that actually don't change? Well, as it happens, the value prop that you pass to the provider is going to be compared shallowly with object.is, or basically a triple equals. And so when this app provider is re-rendered, then this value gets recreated. It's a brand new array. And so when React compares the value we're passing to this provider between the last render and the new one, it says, hey, you gave me a different array last time. And so one way we can solve this is using react.useMemo. And then we'll pass our dependencies, which will include the state. We also could include the dispatch, but the reason the ESLint rule isn't warning us about that is because the dispatch is guaranteed to be stable. And so because ESLint can see that, oh, this is coming from use reducer, I know that dispatch is stable, so I don't need to include it. But honestly, there's no harm in including it if you want to. It won't warn you about that either. So with that now, if I save this, I'll re-record, I'll click force re-render, and I'll stop, and we are taking advantage of our memoization here now because React sees this value and says, oh, okay, so that value hasn't actually changed. It's the same value you gave me last time because none of these dependencies changed. So therefore, I do not need to re-render all of the context consumers, and we have a much better user experience for that particular interaction. In review, all that we did here was take that state and dispatch array that we were assigning to the value, and we memoized it using react.useMemo. So one reason to use useMemo is to save ourselves a bunch of work, and the other reason is to give us a stable value. Now, you'll read in the docs that React does not guarantee that this value will always be the same as the last time it was called. Sometimes React may remove that memoized value to free up some memory. That's currently not something that is going to happen, and even if that were to happen, the only situation where it would matter would be a situation in which React thinks that doing so will actually improve performance. So you don't really need to worry about that for most cases. And in our case, memoizing that context value is giving us a pretty significant savings on re-rendering. Another thing to keep in mind here is we want to compare the before and after. So if you want to, you can go ahead and build the exercise in the final version for production or whatever, but we actually do have the deployed versions. So let's go ahead and take a look. We've got our exercise on the left and the final version on the right. So I will record this. We'll hit force re-render, and then we'll stop it. And then on this side, I'll record. We'll hit force re-render, and then stop. And there we go. We've got a bit of a spike right here. And yep, that's where we clicked that button. And so I think we may have improved that. That was 36 milliseconds before. And let's see if we can find where that happened right here. Yeah, I can barely even see it. So it's significantly improved there. So we're going to go ahead and keep this optimization.